The number everyone heard last summer was 1,350. That's how many earthquakes the U.S. Geological Survey initially confirmed during the largest swarm ever recorded at Mount Rainier, and it was already enough to make national headlines and trigger genuine concern across the Pacific Northwest. But that number, it turns out, was only the earthquakes strong enough to be individually pinpointed in real time. When scientists went back afterward and applied a more sensitive detection technique to the same raw data, the real total wasn't 1,350. It was roughly 8,800. And buried inside that far larger number, researchers found something genuinely new: 48 distinct, repeating earthquake families, clusters of quakes so similar to each other in their seismic signature that they're almost certainly being generated by the exact same tiny patch of rock, rupturing again and again in the same spot. That's the kind of detail that sounds, on its face, like exactly the warning sign people worry about when they hear America's most dangerous volcano. Today, we're breaking down what these repeating earthquake families actually are, why scientists went looking for them in the first place, what a separate viral misinformation scare revealed about how quickly Rainier rumors can spiral, and where the mountain's activity actually stands right now in August 2026. No exaggeration, just the science straight from the USGS and the Pacific Northwest Seismic Network. If you want to keep following developments at Mount Rainier as they happen, subscribe and turn on notifications. A thumbs up helps this information reach more people living in this region. Let's get into it. Let's start with why Mount Rainier carries the label most dangerous in the first place, because it's genuinely important context before diving into this year's specific findings. Mount Rainier stands 14,410 feet tall L, the highest peak in the entire Cascade Range, located in Pierce County, Washington, roughly 59 miles southeast of Seattle. The USGS classifies it as a stratovolcano composed of andesite to dacite rock, and critically, its official threat potential rating. I, based on the National Volcano Early Warning System, sits at very high, one of the highest designations the USGS assigns to any volcano in the country. That rating doesn't come from Rainier being unusually likely to erupt soon. It comes from a combination of factors. The volcano's massive load of glacial ice sitting directly above rock that has been chemically weakened over thousands of years by volcanic gases. And the fact that hundreds of thousands of people now live in valleys built directly on top of ancient volcanic mudflow deposits from the mountain's past. During an eruption roughly 5,600 years ago, the once higher summit of Mount Rainier actually collapsed entirely, forming a large crater open to the northeast, remarkably similar to what happened at Mount St. Helens after its far more recent 1980 eruption. Rainier's most recent confirmed eruption occurred roughly 1,000 years ago, with smaller steam-driven explosions recorded as recently as 1894. Now, let's get into what actually happened last summer, because it's the foundation for everything scientists have been analyzing since. The largest earthquake swarm ever recorded at Mount Rainier began on July 8, 2025, at 1:29 in the morning, and continued generating detectable activity through August 25th of that year. At its initial peak, the USGS confirmed the swarm had produced more than 350 individually located earthquakes, alongside thousands of additional tremors, too small to precisely pinpoint using standard detection methods. The largest single earthquake in the entire sequence measured just magnitude 2, 42, recorded on July 11th, far too small to be felt by anyone standing on the mountain, let alone anyone in the surrounding towns. The average depth of these earthquakes sat at about 2, 8 miles beneath the summit, and throughout the entire event, the USGS Cascades Volcano Observatory kept Rainier's volcano alert level at normal and its aviation color code at green, the lowest possible designations on both scales because everything about the swarm's behavior matched a well-understood non-eruptive process rather than magma actually moving toward the surface. Here's where this year's follow-up analysis becomes genuinely interesting, because scientists didn't stop at that initial 1,350 figure. According to detailed reporting on the swarm's aftermath, researchers at the Pacific Northwest Seismic Network went back through the complete raw seismic dataset using a technique called template matching, a method that searches for smaller, subtler earthquake signals that resemble the waveform pattern of already confirmed events, essentially teaching the detection system what a Rainier earthquake specifically looks like, and then hunting for every instance matching that exact signature throughout the entire swarm period, even signals too weak to trigger standard automatic detection. That more sensitive reanalysis pushed the total count dramatically higher, revealing roughly 8,800 distinct earthquakes total, more than 6 times the originally confirmed number. And within that larger, more complete data set, researchers identified 48 separate repeating earthquake families. It's worth taking a moment to genuinely understand what a repeating earthquake family actually is, because the term itself explains why scientists pay close attention to this specific kind of pattern. When an earthquake's seismic waveform, essentially its unique vibrational fingerprint as recorded by seismometers, closely matches the waveform of previous earthquakes recorded at the same general location. And that's strong evidence the quakes are being generated by the same small patch of rock slipping repeatedly over and over along the same tiny fault surface, rather than by different unrelated cracks forming randomly throughout the volcano's plumbing system. Finding 48 distinct families of this kind within a single swarm tells researchers that specific discrete locations beneath Rainier's hydrothermal system were repeatedly failing and re-rupturing throughout the 2-month sequence, rather than the swarm representing one broad disorganized burst of unrelated cracking spread randomly through the rock. So why isn't this considered alarming, given that it sounds, described that way, like exactly the kind of organized repeating pattern you might expect to precede something bigger? This is where the broader context scientists gathered throughout the swarm becomes essential to understanding the full picture. Seismologists at the time were explicit about exactly what would have constituted a genuine change in Rainier's behavior, and repeating earthquake families weren't on that list. According to the USGS's own contemporaneous analysis published during the swarm, researchers stated directly that if conditions were becoming abnormal, they would expect to see the earthquakes shallow over time or change their fundamental characteristics, specifically flagging that a shift toward what are called hybrid or low-frequency earthquakes, waveform signatures associated with fluid or magma movement rather than simple rock fracturing, would be the kind of change that would indicate something genuinely different happening. Throughout the entire swarm, the earthquakes remained classic volcanotectonic events, the standard signature produced by rock cracking under stress, with no shift toward those more concerning hybrid or low-frequency signatures at any point. Beyond the seismic data itself, scientists deployed multiple other independent monitoring tools, specifically to rule out the more serious possibility that magma was actually rising toward the surface. GPS stations, that gas data, combined with the absence of deformation and the absence of any shift in earthquake character, gave researchers real confidence in their conclusion that this swarm, and by extension the 48 repeating earthquake families discovered within it, represented what scientists directly termed a plumbing event, water and fluid moving through and repeatedly refracturing small sections of the volcano's existing hydrothermal system, not molten rock forcing its way toward the surface. By August 25, 2025, the USGS formally confirmed that earthquake activity at Rainier had returned to typical background rates, which the observatory notes has averaged about 10 earthquakes per month for the several decades prior to the swarm. The agency's official information statement did include one specific, honest caveat worth understanding, that the hydrothermal processes believed to have caused the swarm might still be continuing at levels too small to generate detectable seismicity, meaning there remained a small chance of brief, renewed increases in seismic activity beneath the volcano in the following days or months. That caveat turned out to be reasonably prescient, though not in a way that indicated any escalating danger. That brings us to a genuinely separate but closely related story that unfolded just months later in November of 2025, and it's worth including here because it illustrates exactly how quickly misinformation about a place like Rainier can spread and how seriously scientists have to work to correct it. A viral online report began circulating claiming Mount Rainier was experiencing significant new tremor activity, with some coverage specifically framing it around America's deadliest volcano facing a fresh eruption threat. The Pacific Northwest Seismic Network moved quickly to push back directly, stating plainly in an official release that there was currently no unusual seismic activity at Mount Rainier. The actual cause of the confusion turned out to be entirely mundane, an erratic signal recorded on a single high-altitude monitoring station, one specifically located near the summit and identified by its station code, STAR. By the following Monday, that station's display had become nearly a solid black stripe, suggesting almost constant motion, a pattern that, taken completely out of context by anyone unfamiliar with how seismic instruments actually work, could understandably look alarming. But PNSN seismologist Harold Tobin was direct about the actual explanation, stating clearly that there's a very obvious difference between a genuine earthquake signal or volcanic tremor and what instead looked like a transmission or equipment problem with the data itself. Meteorologists separately confirmed heavy snowfall and freezing fog around the summit area during that exact window, conditions fully consistent with rime ice building up on the station's antenna, a known, well-documented cause of exactly this kind of erratic instrument noise. Crucially, PNSN emphasized that every other monitoring station on the mountain showed completely normal activity throughout, with none of the genuine expected warning signs present anywhere in the broader network. No increase in volcanic earthquakes, no ground swelling, and no change whatsoever in the official alert level. The abnormal signal was isolated entirely to that one malfunctioning station, not a mountain-wide phenomenon. That episode is genuinely useful context for understanding how a story like this one should actually be read and interpreted. A single, unusual reading, whether it's an equipment glitch or a genuinely new scientific finding like the 48 repeating earthquake families, needs to be evaluated against the entire multi-instrument monitoring picture, not treated in isolation as proof of anything on its own. That's precisely the discipline scientists applied both to last summer's genuine large earthquake swarm and to November's false tremor scare, cross-checking seismic data against deformation measurements, gas chemistry, and visual monitoring before drawing any conclusions, and being willing to publicly walk back or correct a story the moment the fuller data set made clear what was actually happening. So, where does Mount Rainier's activity actually stand right now, in August 2026, a full year after that historic swarm began? According to the most recent tracking from Volcano Discovery, drawing directly from USGS reporting, a magnitude 2.2. 4 earthquakes struck roughly 22 kilometers east-northeast of Ashford, Washington, on Saturday, August 1st, 2026, the most notable single event recorded in the past 30 days near the volcano. That's a genuinely modest, unremarkable earthquake on its own, well within the range of Rainier's typical background activity. And it hasn't triggered any change to the mountain's alert status. The observatory alert level remains at normal, the lowest tier on the USGS's 4-level scale. And the aviation color code remains green, also the lowest tier on its corresponding scale, exactly where both readings have sat continuously since well before last summer's historic swarm even began. It's worth stepping back and putting all of this together into a single, coherent picture, because that's really the point of a story like this one. Mount Rainier is, without question, an active volcano, and the USGS's own very high threat rating reflects genuine, serious hazards this mountain poses, primarily through lahars, the fast-moving volcanic mudflows capable of racing down river valleys and devastating communities with very little warning, hazards that don't require an actual eruption to occur. That risk is real, well documented, and part of why Pierce County and Washington State continue investing in lahar detection systems and running evacuation drills in towns like Ording, sitting directly within historically mapped mudflow inundation zones. But the specific, detailed scientific story of what happened at Rainier throughout 2025 and into 2026, the record-breaking swarm, the deeper template matching analysis that revealed 8,800 total events and 48 repeating earthquake families, the targeted gas sampling helicopter flight, and even November's viral misinformation scare, all point toward the same consistent conclusion. Every specific indicator scientists actually rely on to detect genuine volcanic unrest, deformation, gas chemistry, and shifts in earthquake character toward hybrid or low-frequency signatures has remained firmly within Rainier's normal, well-understood range throughout this entire period. The 48 repeating earthquake families represent a genuinely fascinating, newly documented pattern in how Rainier's hydrothermal plumbing behaves under stress, valuable scientific data that will likely inform how researchers interpret any future swarms at this same mountain. But fascinating and scientifically significant is not the same thing as alarming, and researchers have been consistently clear, transparent, and specific about exactly why this particular finding falls into the former category rather than the latter. For anyone living in the shadow of Mount Rainier right now, in Orting, Puyallup, Tacoma, or anywhere across the broader Puget Sound region, the practical takeaway from this entire, genuinely detailed scientific story is straightforward. The volcano remains under continuous, sophisticated multi-instrument monitoring, seismometers, infrasound sensors, GPS stations, webcams, and periodic targeted gas sampling flights when circumstances specifically call for them. That monitoring network correctly identified last year's historic swarm as a hydrothermal plumbing event within weeks, using real, converging evidence rather than guesswork, and it correctly and quickly debunked a viral false alarm just months later using that exact same rigorous multi-source approach. Knowing your community's lahar evacuation route and understanding the difference between Rainier's routine, ongoing background seismicity, and a genuine confirmed change in the volcano's behavior remains sound, practical guidance, independent of whatever the next headline about the mountain happens to say. We'll keep tracking Mount Rainier's activity closely and bring you updates the moment anything genuinely changes and the data scientists actually rely on. Subscribe so you don't miss it, and drop a comment letting me know if you live anywhere near Rainier and how closely your community follows stories like this one. Stay curious, stay prepared, and I'll see you in the next one.